In question number 3, we have a simple pendulum of mass m and length L, and it has a period of oscillation of t. And that's when the amplitude is 5 degrees when measured from the equilibrium. So now we increase the amplitude to 10 degrees and everything else is constant. They want to know the new period of the pendulum. This requires some understanding of how period is related to the different variables in a pendulum. The only thing that changes the period of a pendulum is its length. And there's a formula which is 2 pi root L over G, and this is given to you on the yellow equation sheet. So you should recognize then that as long as you're on the surface of the planet when you're comparing pendulums, and you're not, a pendulum isn't in free fall, or you're comparing one pendulum to a pendulum on a different planet, G remains constant from one pendulum to the length. Notice you could increase the mass, and it's not represented in this formula. It doesn't affect period, and also amplitude does not affect period. So the correct answer to this one is C, and we could just end it there, but it is important to remember that if you look at the derivation for the period of a simple pendulum like this, it's based on a low amplitude oscillation. Typically anything less than 15 degrees, and this works really, really well. However, as you start to get to larger amplitudes, larger angles, if you will, from the equilibrium position, perhaps 30, 45, 50, and 60 degrees, this starts to break down and is no longer valid. But at these low amplitudes, this works just fine, and the correct answer is C.